So I just want to give you some background as to what Bayes' theorem is all about. Talk a little bit about who Thomas Bayes was and some of the uses of Bayes' theorem currently in machine learning. Then we'll look at how the formula is developed and then how it is used. Thomas Bayes, he was a mathematician and a theologian at the University of Edinburgh. He developed a formula because he wanted to refute claim by one David Hume. The formula remained unpublished until 40 years later before Pierre Saint-Glass actually made this popular. What Bayes' theorem is an inverse probability theorem. You want to find the probability of A given B, but what you know is the probability of B given A. This theorem is used quite extensively many different types of machine learning algorithms. This is an example of a naive Bayes classifier. Probability that a patient would belong to either of these class would change based on some new evidence we have. Simultaneous localization, mapping, regularization, some examples of the use of Bayes' theorem currently. Basis for a Netflix contest win of $1 million some 10 years ago. Uda Koren and his team who won the prize, he actually, his PhD thesis was on Bayes' theorem, and so he was able to incorporate that to help him find the winning recommendation filter for Netflix. Bayes' theorem is also used in all of your Google searches. It's what allows Google to, rapidly search through billions of pages and come up with the two most relevant ones in half a second. Similarly, Bayes' theorem is used quite extensively in spam filtering, to determine whether a piece of mail is spam or not, based on the probability of certain pieces of information about that mail. So if we know the probability of, say, something having a certain word in it, then that changes depending on what other words are there in the mail. And so the recommendation systems used by Microsoft for their question and answering, their handwriting recognition, all of these are based on Bayesian inferences. So now moving on to back to probability. Let's see what exactly is this Bayes formula. And so this is the general formula for probability. It's the ratio of the likelihood of an event. It's the ratio of the event of interest relative to the total number of possible outcomes. So we know we can have independent events, or we can have intersections, we can have unions, depending on whether the events are exclusive or inclusive, and we can have dependent events. And these dependent events is where we have the conditional probability. So we can have the probability of A given B is going to be the probability of A intersect B divided by B. Right, so that is the conditional probability. And so we can use that now to give us an idea of what Bayes' theorem is all about. And so the formula for Bayes' theorem is this. But here's how it's developed. The probability of A intersect B is the probability of A given B times the probability of B. But it is also the probability of B given A times the probability of A, right? So because this section here, B intersect A or A intersect B is the same, then these two equations are also the same. So this is equal to that. So if we want to solve for the probability of A given B, then it's the probability of B given A times the probability of A divided by the probability of B. And so that is the essence of the Bayes theorem. What changes is this probability of B is determined using the law of total probability. So this is what it looks like in a tree diagram, right? So we want to know what is the probability of A given B. So we have what we do know is the probability of B given A. We know the probability of A, and so the probability of A given B is the probability of B given A times the probability of B, but we want to normalize it by the probability of B. And so to get the probability of B, we have to find all of the times that we have to sum the probability of B's. So we have to find this probability of B given not A, and this probability of B given A. And so we sum those two to get the probability of B. So that's what our lovely, Bayes theorem is all about, right? So if we wanted to find the probability of